Welcome back. So let's continue with relative molecular or relative atomic mass first. Relative atomic mass, which is also written as AR, right? So when we say relative atomic mass, what is this? So this is, the relative atomic mass of an element is the way average mass of one atom, and we are going to compare this mass to 1 by 12th the mass of carbon 12 atom. This is called relative atomic mass. So the relative atomic mass is, now the question is how to determine. So it is determined by using weight average masses of isotopes. So we can say relative atomic mass is determined by using weighted average mass of isotopes of a particular element. Right? Now, is there any unit? So it's no. There is no unit of atomic, the relative atomic mass, because it's a ratio. So ratio means it get cancelled out. So we can, at the end, we can write the formula that weight average mass of one atom of an element, right, divided by 1 by 12th mass of one atom of carbon 12. Let's have some examples. Okay, so let's say question is, or let's say take an example of some substances, right? So first we have, let's say, hydrogen, right? How many atoms are present and their mass, molecular mass? Let's see. So we have two hydrogen, right? So mass will be 2 into, we know the mass of hydrogen 1.01. You can check this with the data booklet and answer will be 2.02. If I am going to take water, H2, so there is 2 hydrogen and 1 oxygen. So this will be 2 into 1.01 plus 16, and you will get 18.02. If I have to calculate, let's say, CaOH2, calcium hydroxide. So we have 1 calcium, right? We have 2 oxygen and we have 2 hydrogen. So it is written like this. Mass of calcium is 40.08. And there's a bracket, right? So bracket means it is now going to be multiplied, right? So just see here, multiplied with whom? I'm putting a bracket, 2 into 16, close the bracket, and now plus again 2 into 1.01 and if you will calculate, you will get 74.10, right? Why 2? Because OH is whole 2, that's why. 4. Let's say if I am writing ammonium sulfate, NH4 whole 2 and SO4. How to do? So there is a 2 nitrogen plus 8 hydrogen plus 1 sulfur plus 4 oxygen. So it will be 2 into 14.01 plus 8 into 1.01 plus 32.07 plus 4 into 16 equals to, I will get 132.17 gram, right? So this is how we can calculate. Now, how to find the relative formula mass? Let's talk about that. Okay, so this is easy. You can able to calculate. Let's say you have to do the calculation for relative formula mass, and we write it as MR. What is this? So relative formula mass is used for compound containing ions. So we can say used for compound containing ions, right? And it is calculated in the same way how we calculate the relative molecular mass. So we can say can be calculated in same way as relative molecular mass. And so if you can see here, let me give you an example of let me show you this one. If I am going to write, let's say take an example of potassium carbonate, let's say K2CO3 potassium carbonate. So how many potassium you have? So you have 2 potassium plus 1 carbon plus 3 oxygen. So what will be the mass? So mass will be 2 into 39.10 plus carbon is 12.01 plus 3 into 16. I'm going to get 138.21. So this is how you can calculate. This is an easy way where you can do the calculations as per required, right? You can, if you can see these 2 examples, these all are a kind of examples. We can use it to calculate the relative formula mass, right? Okay, so let's continue with the next part. Let's say how to find the molar mass. Let's talk about that. What is molar mass? So since atoms are first of all very small, right? So any sensible laboratory quantity of substance must contain a huge number of atoms, right? Such numbers are not convenient to work with because they are very, very less, very small mass. So using moles is a better unit to deal with these kind of quantities which are very small and not easy to measure. Now, when we need to know the number of particles of a substance, we usually count the number of moles. So the number of moles you can find out with this triangular concept, right? So the triangular concept is, here you have particle. Let me make a big triangle, so that will help. Okay, so let me take a shape. If I can draw a shape triangle, okay, got it. Let me make it bigger. Okay, great. Okay, fair enough. So let me take a, so I can divide this particular triangle into three parts like this. So this is particle, this is moles, and this is L. Now what is L? L is Avogadro's number, and we know the value 6.02 into 10 to the power 23 whole inverse. So now let me put the, so we have to divide when we are, let's say you want to find the moles. So you want to find the moles, so you have to multiply Avogadro number with particles. Let's say if you want to find Avogadro number, then you have to divide with the particles with the mole. So this is a triangle concept. So the formula triangle diagram is, this is formula triangle. So this will help to, so it is linking moles, particles, and Avogadro number or Avogadro constant. So these will help us to find out anything, whatever we want to calculate, right? So let's take an example. Let's say, now you can also write as a formula. So this is written as, use another marker. Okay, so this particle is written with capital N, moles are written in small n, and this is L. So if, let's say, if you want to go from particles to moles like this, let's say, let's find the connection between these two. So N is number of particle, right? So when I'm saying particle, it may be atom, it may be molecule, it may be ions, right? N is moles, L Avogadro number. So N number of particles will be, formula is N into 6.02 into 10 to the power 23. This is the formula. And if you want to find out moles, you just have to divide. So N will be N divided by 6.02 into 10 to the power 23. Understood? So if you want to remember the memory trick, I can write here memory trick. So first is multiply by Avogadro's number to go from moles to particles, right? And divide by Avogadro number to go from particles to moles. That's it. So if, let's say, I have a question, I'm just writing, I don't want to go in the next board. Let's say the question is 2 moles oxygen molecule. How many particles they have? Simple. Just write 2. N is 2. Small n is 2 here. Multiply with 6.02 into 10 to the power 23 and you will get 1.204 into 10 to the power 24 particles, right? So this is just a simple question. So what we have understood, if you want to calculate particles, that means moles into Avogadro number. If you want to find out moles, it's particles divided by Avogadro number. That's it. Done. So let's say the question is, let me come to a question. How many hydrogen atoms are in 0.010 moles of CH3CHO? Okay, let's calculate one by one. So there are 4 hydrogen atoms, right? If you can, so this is CH3CHO. So actually I can break it like this. Right? So we have hydrogen 1, 2, 3 and 4. So there are 4 hydrogen atom in one molecule, and one molecule of CH3CHO, right? So can I say that there are 0.040 moles of hydrogen atom in 0.010 moles of CH3CHO, right? Check. Now, number of hydrogen atom is the amount in moles into Avogadro number. So the amount comes to 0.040 into 6.02 into 10 to the power 23. That means it will come around 2.4 into 10 to the power 22 atoms. Right? So 1 mole have, or also if you have a question how this has come, right? So I can say 1 molecule, right, contain 4 hydrogen. So 0.010 moles will contain how much? 0.4 divided by 0.010, which will come around 0.040. Simple. Fine. Okay, let's take another example. Question is, how many moles of hydrogen atoms are in, let's say, 3.612 into 10 to the power 23 molecules of H2O2? How to solve this? So I can say in 3.612 into 10 to the power 23 molecules of H2O2, there are how many? 2 into 3.612 into 10 to the power 23. atom of hydrogen, right? Because there are two, so that's why 2. So there are how many? So if you just calculate, so you'll get 7.22 into 10 to the power 23 atoms of hydrogen. Now the number of moles of hydrogen atom is the number of particles, and with the formula is divided by L, that is Avogadro. So this comes number of particles we have calculated, 7.22 into 10 to the power 23 divided by 6.02 into 10 to the power 23. So 23 gone, we left with 1.2 moles of hydrogen atom, right? Hope you have understood. We'll do more practice on this topic. Let's see you in the next video. Thank you.